Imagine standing outside like a sealed, soundproof laboratory room.
Right, completely cut off from the outside world.
Exactly. And inside that room, your friend is flipping a coin. Now, common sense and, the entirety of classical physics tells you that the coin is already heads or tails.
Right, it has definite state.
Yeah, you just don't know what it is yet. But what if I told you that in 2018, a team of physicists mathematically proved that if you apply the strictest, most fundamental laws of nature to that room, the coin, the room, and your friend literally do not have a fixed physical reality until you actually open the door?
It completely shatters the very foundation of how we experience the world.
It really does.
We are so conditioned to believe the universe is this, like, objective stage, right?
Yeah.
And we are just the passive audience sitting in the dark watching the play unfold.
Yeah.
But the deeper we probe into quantum mechanics, the more that separation just, well, it collapses entirely.
Welcome to the deep dive. Today, we are undertaking a massive exploration into the profound, this really shifty split between the observer and reality.
It's a huge topic.
It is. We are going to unpack how cutting-edge quantum physics and ancient Buddhist philosophy have arrived at a surprisingly identical, kind of inescapable conclusion.
Which is that the universe doesn't exist out there independently of you.
Right?
Rather, you are deeply, inextricably entangled in creating it just by looking at it.
So to guide us through this ontological labyrinth, we have a really towering stack of source material today.
We really do.
Yeah.
We're drawing from some foundational papers on quantum paradoxes, starting with Eugene Wigner's iconic 1961 essay on the mind-body question.
Right, going all the way to the 2018 Frauchiger-Renner thought experiment, which essentially, well, it broke standard quantum theory.
Completely broke it, and we'll explore radical modern frameworks like relational quantum mechanics, which is detailed in Carlo Rovelli's book Helgoland.
Great book.
Yeah, it's brilliant. And we'll also get into quantum Bayesianism, or QBism.
And then we are taking those modern physics papers and overlaying them onto the transcripts from the 2007 Mind and Life dialogue in Dharamsala.
Right, that's where the Dalai Lama met with leading quantum physicists to discuss the Mahayana Buddhist concept of the middle way.
Yeah, so we're incorporating academic analyses, linking the Buddhist Heart Sutra to quantum field theory, and diving into the underlying mathematics of these paradoxes via an incredible breakdown by Jeffrey Epstein on the Quantum Frontiers blog.
It is just an immense journey. We are going to see how a technical argument over a scientist making a measurement forces us to abandon our Western materialist understanding of reality.
Yeah, leading us straight into the ancient 2,000-year-old concept of emptiness.
Absolutely.
So before we can understand how ancient spirituality aligns with modern physics, we really have to look at the specific crack in the foundation that brought the physicists to this precipice.
Right, where it all started to go wrong.
Exactly. We need to talk about the measurement problem, and specifically the thought experiment known as Wigner's friend.
That is the perfect starting point, because it isolates the exact moment physics stopped being able to describe an objective universe.
Right.
Now, Eugene Wigner was a Nobel laureate. He was a giant in the field who won his prize for his contributions to the mathematical foundations of quantum mechanics.
So he wasn't some fringe philosopher.
No, not at all. He was a serious, rigorous mathematician. But in 1961, he published an essay titled Remarks on the Mind-Body Question, and it completely defied the materialist consensus of the era.
Because up until that point, materialism was the undisputed king, right?
Oh, absolutely.
The success of macroscopic physics, building bridges, launching rockets, made it obvious to most scientists that the mind, or the soul, was just an illusion created by atoms bumping into each other.
Yeah, just biology doing its thing.
Yeah.
But Wigner looked at his own equations and said, no, we actually can't formulate the laws of physics consistently without putting human consciousness at the very center of the math.
Which is wild.
It is. And to prove it, Wigner formulated a thought experiment. He imagined a scenario where he places a friend, let's call her Alice, inside a completely isolated, perfectly sealed laboratory.
Okay, so she's in the box.
Right. Inside this lab, Alice is instructed to measure a quantum system. Let's say she's measuring the spin of a single particle, which can only be one of two states, spin up or spin down.
So Alice runs her machine, she looks at the dial, and she gets a definite result. She sees spin up.
Exactly.
For her, the event is over. The reality of that particle is cemented.
But Wigner places himself outside the laboratory. He is completely physically isolated from Alice and her particle.
Right.
And according to the strict linear equations of quantum mechanics, specifically the Schrödinger equation, which dictates how physical systems evolve over time. Because Wigner has not yet interacted with the laboratory, he is mathematically forbidden from treating the particle as having a definite state.
Okay, let's unpack this, because this is where classical logic always rebels for me.
Fair enough.
If I am standing outside your house while you roll a die, the die has landed on a 6. It's a 6 whether I know it or not, right?
That's a classical intuition, yeah.
My ignorance doesn't make the die magical. Why can't Wigner just say, Alice rolled a 6, I just don't know it yet?
What's fascinating here is the crucial distinction between classical ignorance and quantum superposition. And it has to do with something called interference.
Okay.
In classical physics, if you don't know the outcome, you use standard probability.
Yeah.
A 50% chance of heads, a 50% chance of tails.
Right.
But in quantum mechanics, a system in a superposition isn't just one or the other, but we don't know. It is mathematically exploring both possibilities simultaneously.
Wait, simultaneously?
Yes, and those possibilities can physically interfere with each other, like ripples on a pond crashing into one another and creating new patterns.
Oh, wow.
So if Wigner assumes Alice already has a definite result, he will completely botch his mathematical predictions for any future experiment he might do on the whole laboratory. The math literally demands he treat the entire room as a wave of uncollapsed potential.
So Wigner isn't just saying the particle's in a superposition. He is forced by his own equations to model his friend, a living, breathing human being, as being in a state of suspended animation.
Exactly. A mathematical smear of Alice saw spin up mixed with Alice saw spin down.
That's terrifying.
It is. And that is the paradox, because Wigner eventually opens the door and asks Alice what she saw.
Right.
She says, I saw spin up. Now, Wigner's wave function for the room collapses into reality. But Wigner asks her a follow-up question. He asks, what did you feel about the result before I opened the door?
I mean, she would look at him like he was crazy.
Totally.
She'd say, I knew the result 10 minutes ago when I looked at the dial. I wasn't floating in a cloud of probability just because you hadn't opened the door yet.
Precisely. Alice's subjective experience proves she possessed a definite state long before Wigner's equations said she did.
Okay.
So Wigner realized that if his friend's mind can collapse the wave function internally, then human consciousness cannot be subject to the linear equations of quantum mechanics.
Wow.
The mathematics must physically break down when they encounter a conscious observer.
So Wigner basically waved a magic wand and declared Cartesian dualism the winner. He said the mind is fundamentally separate from physical matter, and the mind exerts a real physical force that collapses matter into a fixed state.
Yeah, he called the objective collapse caused by consciousness. And as you can imagine, this made the broader physics community incredibly uncomfortable.
Oh, I bet. Physicists abhor magic.
They really do. They abhor the idea of introducing an unmeasurable mystical force called consciousness into their pristine mathematical models. It felt like, retreating to the Dark Ages.
Which makes you wonder, if the physics community hated Wigner's magical consciousness wand, they must have tried to prove him wrong using standard, rigorous math, right?
They did.
Did anyone actually run the numbers on what happens if we don't assume consciousness is special? Like, if we treat humans just like any other physical system?
They did, and it led to an even more terrifying conclusion. This brings us to the 2018 Frauchiger-Renner thought experiment.
Okay, the one that broke everything.
Yes. Daniela Frauchiger and Renata Renner decided to scale up Wigner's friend to expose the logical limits of standard quantum theory.
How did they do that?
Instead of one Wigner and one friend, they created a nested Russian doll of quantum measurements involving 4 completely rational agents.
4 of them.
Yeah, Alice, her friend Bob, and 2 super observers, Wigner 1 and Wigner 2.
Okay, 4 agents, all using flawless textbook quantum mechanics.
All operating in isolated labs, measuring each other in a very specific sequence.
Walk me through it.
So Alice measures a quantum coin. Based on her results, she prepares a new quantum particle and sends it to Bob in another lab.
Okay, Bob gets a particle.
Right. Bob measures that particle. Then Wigner 1 measures Alice's entire laboratory. And Wigner 2 measures Bob's entire laboratory.
That is intensely complicated. But the goal is to see if all 4 of these brilliant scientists can agree on what actually happened, right?
Yes. Frauchiger and Renner formalized 3 standard assumptions that every physicist relies on. Assumption Q is that quantum theory is universally correct, specifically the Born rule for calculating probabilities.
That makes sense.
Assumption C is that agents' predictions are consistent, meaning if I logically deduce that you know a fact, then I am allowed to know that fact too.
Sure.
And assumption S is that a measurement always yields a single definite outcome.
Wait, those don't even sound like assumptions. Those sound
Yeah.
like the bare minimum requirements for reality to function.
Right.
I mean, if measurements don't yield single outcomes, and if logically consistent scientists can't agree on basic facts, then the scientific method itself is basically broken.
Well, the devastating result of the Frauchiger-Renner paper is that when you run the math on this four-agent scenario, those three assumptions create a fatal illogical contradiction.
A contradiction how?
Through a series of mathematically sound deductions, Agent A will prove with 100% certainty that the final measurement will be heads.
Okay.
Meanwhile, Agent B, using the exact same flawless equations, will prove with 100% certainty that the final measurement will be tails.
Wait, if they are both using the exact same universally accepted equations, then the math isn't just breaking down, the math is lying to them. How is that even possible?
The authors concluded their paper with a chilling sentence. They wrote, "Quantum theory cannot consistently describe the use of itself."
Oh, wow.
Yeah. If you assume reality is objective and you assume quantum mechanics applies universally, the universe contradicts itself. You are forced to abandon at least one of those three core assumptions about reality.
So if Wigner's mind-body magic is unacceptable, and the Frauchiger-Renner experiment proves that treating everything as a standard objective physical system leads to catastrophic paradoxes, what do we throw out?
It's a huge problem.
How do modern physicists escape this trap?
The only viable escape hatch is to completely dismantle our definition of what a quantum state actually is.
Really?
We have to abandon the idea of an objective, global reality. This paradigm shift birthed two major frameworks in modern physics: relational quantum mechanics and quantum Bayesianism, or QBism. Let's look at relational quantum mechanics, or RQM, championed by Carlo Rovelli in his book Helgoland.
I love the title Helgoland. It refers to the barren, windswept island in the North Sea where Werner Heisenberg retreated in the 1920s, right?
Yes.
To escape his severe allergies, and he ended up essentially dismantling classical reality.
A fittingly isolated birthplace for a theory that isolates us from our classical intuition. Rovelli looks at the Wigner's friend paradox and says, the mistake we're making is assuming there was a God's eye view of the universe. RQM states that a quantum wave function is not an intrinsic property of a physical system.
Wait, that is a massive conceptual leap. We are taught in school that things have properties. An apple is red, a rock has mass, an electron has a spin.
Rovelli argues that nothing has properties inherently. Properties only exist as a relation between two systems.
Like what?
Think about velocity. If you are sitting in a train moving at 100 miles an hour, what is your velocity?
Well, relative to the train tracks outside, it's 100 miles an hour. But relative to the coffee cup sitting on the table in front of me, my velocity is 0.
Exactly. You do not possess an absolute velocity inside your body. Velocity is a relational fact.
Okay, I track that.
Rovelli says every single physical property in the universe works like that. Position, momentum, spin, mass, they're all relational.
All of them.
Yes. So go back to Wigner and Alice. Alice measures the particle as spin-up. Relative to Alice, the particle is spin-up. Wigner measures the laboratory. Relative to Wigner, Alice and the particle are in a superposition.
So if I'm walking down the street and I ask Rovelli who is right, Alice or Wigner, what does he say?
He says the question itself is meaningless. They are both right.
Both.
Alice is describing reality relative to Alice. Wigner is describing reality relative to Wigner. There is no absolute objective reality floating above them that they're trying to uncover.
That's wow.
Reality is just the infinite network of these localized relational interactions.
That solves the paradox by just accepting that two contradictory realities can exist side by side as long as they belong to different observers.
Exactly.
But there is a second framework in our source material that goes even further into territory that frankly sounds terrifying. Quantum Bayesianism, or QBism.
Yeah, pioneered in the early 2000s by Christopher Fuchs, Rudiger Schack, and Carlton Caves. QBism takes the relational idea and aggressively centers the agent. If RQM says physical properties are relational, QBism says the quantum state, the actual wave function written on the chalkboard, isn't a physical thing at all. It does not exist in nature.
Then what are the physicists studying? If the wave function isn't a physical wave of probability spreading through space, what is it?
It is purely a mathematical representation of an agent's personal degrees of belief. It is quantified ignorance.
Degrees of belief.
Yes. QBism roots itself in Bayesian statistics, where probability isn't a physical property of an object. In classical statistics, if you flip a coin, you might say the coin has an inherent 50% propensity to land on heads.
Right.
But Bayesian probability says no, probability is just a tool an agent uses to quantify their uncertainty based on the information they currently have.
So when a cubist physicist writes down the Schrödinger equation for an electron, they aren't describing the electron.
No.
They are describing their own internal expectations about what they will personally experience if they interact with that electron.
Precisely. And this radically reframes the most famous rule in quantum mechanics, the Born rule.
How so?
Normally, physicists view the Born rule as a descriptive law of nature, the equation that tells you the physical likelihood of finding a particle in a certain place. But QBism says the Born rule is a normative rule.
A normative rule, meaning it doesn't describe how the world is, it prescribes how an agent should behave.
Yes, it is an empirically derived handbook for a gambler.
A gambler.
Exactly. If you want to place bets on the outcomes of quantum measurements, and you want to ensure your various beliefs remain logically consistent with one another, so you don't lose all your money, you must use the Born rule.
The source texts introduce some dense jargon here, specifically something called the Relational or primal equation and SICPOVMs.
Yeah, quite the mouthful.
If I'm a listener trying to wrap my head around this, what do these terms actually mean in the context of gambling on reality?
They are mathematically intimidating. But conceptually, they perform a brilliant trick. A SICPOVM, which stands for Symmetric Informationally Complete Positive Operator-Valued Measure, is basically a perfect, mathematically elegant set of reference questions you can ask a quantum system.
Okay.
Think of it as a standardized ruler. QBists call it the Bureau of Standards Measurement.
Okay, a Bureau of Standards. So instead of dealing with abstract, invisible waves in multidimensional space,
You calibrate your beliefs against this standardized ruler. The Ergleiching, or primal equation, is the math that allows a QBist to rewrite standard quantum mechanics entirely in terms of standard probability.
oh, I see.
It proves that quantum states are probability distributions over this hypothetical Bureau of Standards measurement. It strips the magic away.
Interesting.
It proves the Schrödinger equation isn't a physical mechanism evolving in reality. It's just a formula you use to update your personal betting ledger.
But I mean, this forces a massive philosophical crisis, doesn't it?
How so?
If probabilities are just in my head and quantum states are just my personal betting odds, isn't this just solipsism?
Ah,
We are essentially saying that if I close my eyes, the universe disappears. If the math only describes my beliefs, where is the actual physical table I am sitting at?
that is the most profound hurdle for anyone encountering QBism, and Christopher Fuchs wrestles with it extensively.
I would hope so.
He vehemently rejects solipsism. He actually coined a term for his philosophy, participatory realism.
Participatory realism. How does that save the universe from just being a figment of my imagination?
It acknowledges that the universe is real and independent. The electron exists. The table exists.
Good.
But, and this is the monumental shift, a measurement is not you passively looking through a telescope to discover pre-existing fact. A measurement is an action you take upon the world, and the outcome is the world's real physical response to your action.
Like a dialogue. The source material uses a prosthetic limb analogy here, right?
Yes, think of a blind person navigating a room with a cane. The cane is not the external environment, but it's also not the brain. It is an extension of the agent.
Right.
The person swings the cane. That's the action. The cane hits a table, sending a vibration up the person's arm. That vibration is the kickback from reality.
The kickback.
Exactly. QBism says a multi-billion-dollar particle collider in Switzerland is conceptually identical to that cane. It is a tool an agent uses to kick the universe. The measurement outcome is the universe kicking back.
That is incredibly vivid. The universe is real, but the properties we observe, spin, mass, position, aren't sitting out there waiting to be found.
No, they aren't.
They are the specific vibrations traveling up the cane. They are the result of the collision between the agent and reality.
Therefore, without the agent's participation, the concept of a physical property is completely meaningless. You cannot remove the observer from the physics. The Wigner's friend paradox evaporates entirely under QBism. Wigner has his cane, he kicks the door, he updates his betting ledger. Alice has her cane, she kicks the particle, she updates her ledger.
So they don't conflict.
There is no contradiction.
Yeah.
Because there is no single global physical state they are disagreeing on. There are only localized, personal experiences of reality kicking back.
This idea that objects have no intrinsic properties, that they only exist in relation to an observer, and that reality is an ongoing participatory event. It sounds like a radical framework dreamed up by a 21st century physicist.
It really does.
But our sources reveal something astonishing. This precise framework is an ancient 2,000-year-old philosophical doctrine, which means we need to leave the European physics labs and travel to Dharamsala, India.
Yes. In April 2007, the Mind and Life Institute hosted an unprecedented gathering. It was their 14th dialogue titled The Universe in a Single Atom.
I've heard of this.
It brought the Dalai Lama into deep conversation with some of the absolute titans of modern science.
We're talking about luminaries like Anton Zeilinger, who later won the Nobel Prize in Physics for his experiments on quantum entanglement. We have Richard Davidson, Arthur Zajonc, and the philosopher Evan Thompson.
It's an incredible lineup. And for decades, the Western worldview treated science and spirituality as entirely non-overlapping magisteria.
All right. Science was the cold, objective study of the external world. Spirituality was the warm, subjective exploration of the internal mind.
Exactly. But in Dharamsala, these physicists found themselves admitting that their multi-million-dollar experiments were mathematically proving that the objective external world is an illusion.
Which is exactly what Mahayana Buddhism has been teaching through the concept of the middle way.
Yes.
The conceptual resonance here is just staggering. Michel Bitbol, a philosopher and physicist, led a crucial presentation during these dialogues on a concept called the defeat of own being.
Right. In Sanskrit, the term for own being is svabhava. It roughly translates to intrinsic existence. It is the deep-seated assumption that a thing possesses its own independent essence. Classical physics is entirely built on svabhava. We assume an atom has a mass, a charge, and a location intrinsically, regardless of whether a scientist, a telescope, or another atom is interacting with it.
It exists from its own side.
Exactly. But Bitbol argued to the Dalai Lama that the paradoxes of quantum mechanics like wave-particle duality or Schrödinger's cat only arise because we stubbornly cling to svabhava.
We want things to be solid.
We demand that an electron is intrinsically a particle or intrinsically a wave. Bitbol pointed out that quantum mechanics dispels these paradoxes the moment you defeat the concept of own being.
Because an electron isn't anything intrinsically.
Yeah.
Its behavior, whether it acts like a localized bullet or a spread-out wave, is entirely dictated by the experimental apparatus the physicist chooses to build. The observer's choice of cane dictates the vibration that comes back.
Yes. And this maps flawlessly onto the foundational Buddhist doctrine of dependent origination. Buddhism states that absolutely nothing in the universe exists independently. Everything is an infinite web of relations.
It's all connected.
Think of a tree. We conceptualize a tree as an independent object, but a tree only exists in relation to the soil that feeds it, the sunlight that hits its leaves, the rain that waters it, and the human mind that arbitrarily draws a conceptual boundary around the wood and leaves and names it tree.
Right.
If you take away the soil, the sun, the rain, and the observer, where is the tree?
Here's where it gets really interesting. It just vanishes.
Exactly.
The treeness isn't in the bark, it is the sum total of its relationships. It is intensely ironic to me. For hundreds of years, Western science was obsessed with the reductionist project.
Finding the building blocks?
Yeah, we wanted to find the ultimate indivisible building block of nature. We smashed atoms into protons, protons into quarks, desperately looking for the fundamental Lego brick of reality, only to zoom in to the very bottom of the universe and realize there are no bricks. There are only relationships.
It really is the death of the materialist dream. You look closer and closer at the object, and the object dissolves, leaving only its interactions with you.
Wow.
This profound realization is codified in the Heart Sutra, perhaps the most famous text in Mahayana Buddhism, through the Two Truths doctrine.
The Heart Sutra distinguishes between conventional truth and ultimate truth.
Correct. At the conventional level, daily life functions perfectly. A table is a table. An electron is an electron.
Makes sense.
But at the ultimate level of reality, the true nature of all phenomena is sunyata.
Emptiness.
But we have to be incredibly careful with the translation of sunyata. In the West, the word emptiness carries a heavy baggage of nihilism.
Yeah, it sounds like a dark, depressing void. It sounds like nothing exists.
Right. But in the context of the Heart Sutra, sunyata specifically means empty of independent existence. It means empty of svabhava.
So it's not saying the table isn't there. It's saying the table isn't a table all by itself. It requires you to sit at it.
Yes.
When Carlo Rovelli writes out the math for relational quantum mechanics, or when Christopher Fuchs argues for participatory realism in QBism, they are basically writing the mathematical proof for sunyata.
That is the compelling argument being presented by the philosophers in our source stack. But to truly grasp how physically real this concept of emptiness is, we have to look past the philosophy and examine what quantum mechanics actually says about the physical fabric of space and time.
Okay, let's do it.
This is beautifully articulated in a QS paper on quantum emptiness by David Leong, which draws heavily from modern quantum field theory.
Now, quantum field theory, or QFT, is arguably the most successful, rigorously tested physical theory humanity has ever produced. It's the engine behind the standard model of particle physics. And what blew my mind reading Leong's analysis is that QFT completely discards the idea of a solid, permanent particle.
We really have to stop thinking of particles as tiny billiard balls. In QFT, particles are not permanent fixtures in the universe. The fundamental reality is not the particle. The fundamental reality is the field.
An invisible, continuous fluid that fills all of space and time.
Exactly. What we call a particle is just a localized, transient excitation, like a temporary ripple, in that underlying field.
Like a wave manifesting on the surface of the ocean. The wave isn't an independent object, it's just the ocean doing something for a second before subsiding.
Perfect analogy. Particles spontaneously pop into existence from the quantum vacuum, they interact, and they annihilate back into the vacuum. They are entirely transient forms.
Okay.
And to calculate how these transient forms move, the text introduces Richard Feynman's path, integral formulation.
This is one of the most conceptually bizarre pieces of math in physics.
It is brilliantly bizarre. Feynman realized that if you want to calculate the probability of a particle traveling from point A to point B, you cannot use classical logic.
Classical logic says a baseball thrown from the pitcher to the catcher takes one single definitive arc through the air.
Right.
If I'm camping in the woods and I walk from my tent to the lake, I take a specific dirt path, I put one foot in front of the other, but quantum mechanics says, what? The particle doesn't do that.
Quantum mechanics says the particle explores every single possible path simultaneously.
Wait, what?
To get the correct mathematical answer, Feynman had to calculate the path that goes straight to the destination, but also the path that zigzags through the forest, the path that goes backwards in time, and the path that travels to the Andromeda Galaxy and back before arriving at the destination.
That's insane.
The particle exists as a superposition of infinite potential trajectories. The reality we finally observe at point B is just the mathematical sum, the interference pattern of all those ghostly, unmanifested hikes.
That is staggering. The solid reality we interact with is just the collapsed sum of infinite, invisible potentials. And Leong's paper connects this directly to the most famous paradoxical line in the Heart Sutra form, is emptiness. Emptiness is form.
It is a perfect metaphor. Think of the underlying quantum field, that invisible ocean of infinite, unmanifested potential, the sum of all possible histories, as the emptiness, sunyata. It is completely devoid of specific, independent particles.
Right.
Then think of the transient ripple, the momentary manifestation of a particle that pops into existence when an observer interacts with it as the form.
Form is emptiness, emptiness is form. The temporary particle is the eternal feel. The observable reality is the underlying potential. You literally cannot separate the wave from the ocean.
They are two sides of the same coin.
Incredible.
If we connect this to the bigger picture, to ground this in how humans experience reality, Leong's text introduces a completely different academic discipline, the application of Pearson semiotics by researcher Søren Breyer.
Semiotics is the study of signs, symbols, and meaning. How does linguistics fit into quantum fields?
Charles Sanders Peirce was a 19th century American philosopher who developed a triad theory of meaning. In semiotics, a sign like a footprint in the mud or a string of letters has absolutely no inherent meaning on its own.
Okay, think of a stop sign. If a red octagonal piece of metal is sitting in the middle of an uninhabited desert, it doesn't mean stop. It doesn't contain a command. It is just metal and red paint.
Exactly. It only becomes a sign when a conscious mind looks at it, processes the cultural context, and extracts meaning.
Okay.
Peirce argued that meaning is an emergent property of the interaction between the object and the observer. Breyer takes this semiotic triad and maps it directly onto quantum mechanics.
So he's saying the universe is full of stop signs waiting to be read.
He's saying the quantum world, the uncollapsed superposition, has no definite physical properties, no intrinsic meaning, until an observer, an interpretant, interacts with it.
Oh, wow.
Both Eastern emptiness ontology and Western semiotics arrived at the exact same conclusion. Reality is a web of relations uniquely shaped by the observer. Physical reality itself is an emergent property of interpretation.
But this brings us to an unavoidable cliff edge. If the physical world is empty and purely relational, and if quantum mechanics absolutely requires an agent to kick the universe and experience a measurement, as QBism insists, then what exactly is this agent?
That is the core issue.
What is the observer? Are we talking about consciousness? Because if we are back to Wigner's magic wand.
This is the million-dollar question, and it is where the deepest fracture points between modern science and Buddhism are exposed.
Right.
We have to return to the transcripts of the Mind and Life dialogues.
Okay.
Evan Thompson, a philosopher of mind, really drilled into this friction. Western cognitive science, neurobiology, is almost entirely built on materialism. It assumes that the brain is entirely necessary and sufficient to produce the mind.
The materialist view essentially says the brain secretes consciousness the exact same way the liver secretes bile. It's just a biological byproduct, an epiphenomenon.
And this view leads to what philosopher David Chalmers famously called the hard problem of consciousness.
Right.
If the universe is fundamentally made of dead, unthinking matter atoms pinging off each other, how does subjective, vivid, first-person experience ever arise from it? How does the firing of a neuron produce the subjective feeling of tasting a strawberry or seeing the color red?
It's a huge gap.
Michel Bitbol, in his presentation Consciousness, East and West, pointed out the fatal flaw in this approach. He described the contemporary materialist approach as treating humans like zombie-like mechanisms.
A zombie mechanism, meaning we are just incredibly complex biological robots reacting automatically to physical stimuli, and our internal sense of me is just a stubborn illusion generated by the software.
Right. Bitbol argues this is a dead end and suggests we need to completely invert our methodology. He advocates for phenomenology.
Phenomenology? What does that inversion look like?
Instead of starting with dead matter and trying to magically build consciousness out of it, phenomenology addresses the problem from the midst of consciousness.
Oh, okay, from the inside.
It posits that your subjective first-person experience is the primary, absolute, undeniable reality. Everything else, tables, chairs, brains, quantum fields, the mathematics of the Schrödinger equation, are secondary concepts constructed within that first-person experience.
So instead of asking the impossible question, how does the physical brain manufacture the mind, you ask, how does my mind construct the physical concept of a brain?
Yes.
It's flipping the entire universe inside out.
And Bitbol explores an even deeper alternative rooted in Indian philosophy, perennial idealism. This perspective dissolves the hard problem of consciousness entirely by proposing a radical shift. Consciousness is not a late-stage byproduct of a dead universe. Consciousness is the fundamental, foundational ground of the universe itself.
Okay, so what does this all mean? Because I have to push back hard here. My alarm bells are ringing.
Let's hear it.
We spent the first half of this deep dive criticizing Eugene Wigner for his dualism, for claiming consciousness was a magical force that breaks the laws of physics. If we are now saying Buddhism believes consciousness is the fundamental ground of the universe, are we saying rocks are conscious?
No.
Are we endorsing mysticism? How is this different from Wigner?
That is the vital distinction, and we must parse it carefully to avoid falling into unscientific mysticism. The experts in our sources are absolutely not saying a rock is having thoughts, or that a tree feels anxiety.
Okay, good.
The difference lies in the architecture of reality. Wigner was a dualist. He believed matter was one distinct thing, and mind was a separate distinct thing that floated in from the outside and bullied matter into shape.
Mind-bossing matter around.
Yes, but the relational view, the QBist view, and the Buddhist view are not dualistic. They argue that subjectivity is a foundational, structural component of how reality operates. Reality is an interaction. The source text introduces the esoteric Buddhist Trikaya doctrine to clarify how this mechanism works without dualism. The Trikaya describes a spectrum of manifestation, how reality transitions from pure potential to physical form.
Walk me through the spectrum. How does a quantum probability become the chair I'm sitting in?
It happens in 3 layers. The deepest layer is the Dharmakaya. This is the realm of pure, unmanifested potential. In physics terms, this is the quantum vacuum, the superposition of all possible Feynman paths. It is formless.
Okay, pure potential.
The next layer is the Samogakaya. This is the subtle realm of relations and information. This is where the interaction begins.
The interaction layer.
Think of it as the mathematical interface where the observer's cane strikes the unmanifested field. It's where the probabilities are calculated.
Got it. And the final layer?
The final layer is the Nirmanakaya. This is the observable material reality we experience every day. It is the collapsed wave function. It is the solid table, the spin-up electron, the vibration you feel in the cane.
And the crucial takeaway is that you cannot get to the Nirmanakaya, the physical world, without passing through the interface of the observer.
Exactly. The material world doesn't exist independently in the dark, waiting to be illuminated. The act of seeing, the subjective cognitive engagement, is structurally necessary to bring the material world into form.
Incredible.
You are not a passive observer of the universe. You are a required participant in its ongoing manifestation.
That is breathtaking. Let me try to synthesize this immense territory we have traversed today. We started in the 1960s with Eugene Wigner and his friend, trapped in a mathematical paradox where quantum equations literally broke down depending on whose perspective was calculated.
Yes.
We saw how the Frauchiger-Renner experiment proved that treating the universe as objective and independent leads to catastrophic logical contradictions.
Completely broke standard assumptions.
Right. To save physics, we had to adopt the relational frameworks of Carlo Rovelli and the participatory realism of QBism, discovering that a quantum state isn't a physical reality, but a subjective ledger of beliefs and relations.
And from there, the philosophical parallels became undeniable.
Yeah, we traveled to Dharamsala and saw how modern quantum field theory provides the mathematical scaffolding for the 2,000-year-old Buddhist Heart Sutra.
That objects lack intrinsic own being.
That reality is a web of dependent origination. That form is just the temporary observer-driven excitation of the underlying emptiness.
It's a beautiful convergence.
The ultimate takeaway for you listening to this right now, whether you are sitting in your car or making coffee in your kitchen, is that reality isn't a pre-recorded movie playing out in front of you.
No, it isn't.
The kitchen counter isn't just there. Your interaction with the world is what literally gives it physical form.
I want to leave you with one final deeply provocative thought to wrestle with, drawing from the Jeffrey Epstein blog post on the Frauchiger-Renner experiment.
Oh, this one is fascinating.
It really is. Epstein mathematically formalized the paradox and searched for an escape hatch. He discovered that the complex mental transitivity required to solve the paradox, the deductive logic of, I know that Alice knows, that Bob knows, can only remain logically consistent if we strictly restrict our analysis to a single space-like surface.
A single space-like surface. For those of us who aren't Einstein, what does that actually mean?
It relies on Einstein's theory of special relativity. Relativity proved there is no universal clock ticking in the background of the universe. There is no universal now. Time is entirely relative to the speed and gravity of the observer.
Okay.
A space-like surface is essentially a mathematical slice of four-dimensional spacetime that represents a single frozen moment for one specific observer.
Okay, so if I'm understanding this, because relativity says we all have our own separate now, Epstein is saying the only way the universe doesn't immediately shatter into a billion contradictory Frauchiger-Renner paradoxes is if we lock reality to these subjective slices of time.
Yes. If relativity dictates that space and time are flexible, personal dimensions, and quantum mechanics dictates that physical reality is entirely dependent on subjective observation, Epstein's mathematical proof points toward a staggering conclusion.
What's the conclusion?
Could our very experience of time passing just be the necessary byproduct of different consciousnesses, different agents, trying to sync up their subjective relational realities?
You're saying time isn't a river we are floating in. Time is just the friction of our minds negotiating a shared reality.
Yes.
Time is the buffer that keeps our subjective universes from colliding.
It is a profound hypothesis that builds perfectly on everything we've unpacked today. If reality is participatory, maybe time is just the mechanism of that participation.
I'm going to be staring at the wall thinking about that for weeks. You know, remember how we used the analogy of a broken X-ray machine earlier? How classical physics gave us a clean black and white picture of a broken bone, and quantum mechanics seemed to smash the machine?
Right, leaving us with ontological muddy waters.
Exactly. What this deep dive shows us is that the X-ray machine was never broken. It's just that the machine was never taking a picture of an independent bone.
No, it wasn't.
It was taking a picture of a relationship, a fleeting, entangled relationship between the machine, the bone, and the mind reading the film. Thank you for joining us on this deep dive. We encourage you to look at the world around you a little differently today. The objects around you aren't ignoring you. The universe is waiting for you to interact with it.